So now I'm going to be talking about lists within Python. Lists are quite different to your standard variables such as integers or strings, and that's because they are arrays of data. They contain multiple variables within them, or multiple pieces of data, not specifically variables themselves. So to demonstrate what I mean by this, I'll declare a variable called thisList, and we're going to make it equal to apple, banana, and cherry. And you can see here that this is a comma separated list, so it's in between each piece of data we are adding a comma to symbolize the end of that piece of data. So this list now contains 3 strings. One says apple, banana, and cherry. And if we print this list to our terminal, or if I can type this list to our terminal and then run it, you can see here we have apple, banana, and cherry. So that's great. And what is really good about lists is we can reference their items using the index of the item itself. And what I mean by this is every single piece of data within an array, it has a position within the array. So in this context, or in this example, apple is the first item, banana second, cherry third. So under the hood, what this means is that Python reads it as in position 0 is apple. Then in position 1 is banana. And then in position 2 is cherry. And the reason that we start from 0 is because in programming, we typically count from 0 when we are talking about most things, including loops. So while we learn to usually count from 1 in school and in most of our lives, we always count from 0 in this context. So the item in index position 0 is apple. And to reference this, after this list variable that we're writing here, I'm going to open some square brackets, and if I hover over it for the type hint, expected index or slice expression, it said something more useful before, but that doesn't matter. So if I put an integer, so 0 there, we're expecting apple to be printed to the console. And that is exactly what happens here. And then I can swap this out for number 1, and we have banana, number 2, dash cherry, and now number 3, as you might expect, throws an index error. So this says that the list index is out of range. It tells me exactly where this error happened. So you see these 3 carets here pointing to where we're referencing number 3. And that's correct. There are only 3 items in the array. We have asked for item at the index position 3, which would be the 4th item, which doesn't exist. So we get that error, and that is expected. What is good about lists as well is that we can add different types of data to the same list. So here I'm adding 2 integers, 1 and 2, and then I'm adding a floating point number, 0.5, and this shouldn't change any of the behavior. We're still able to use and print the list to our console directly. If you'd ever like to know what is within a list, there's a helpful function built into Python, which is len, L-E-N, len, and this is short for length. So when we run the len function and we pass it a list, it will return an integer to represent how many items are in that list, or as you can see from the type hint, return the number of items within the container. So when I run this code, we should see the number, or the integer 6, which we do, which is great. So let's say we have a list that contains a series of integers and we wanted to add something to the list. Well, the way we can do that is by calling a method on the list itself. And what that means is if we go my numbers, which is the name of the list I've declared on top here, we can then put a full stop. And you can see we get a series of options, a series of different methods that we can call to interact with or manipulate this list in some way. So the one I'm talking about now is append, which means to add to the end of something. So if we do my numbers dot append, and then we open some parenthesis, we can append a number. So we're going to do 50. So what I'll do is I'm going to first print the value of my numbers. And then I'm going to take that and I'm going to copy it over here, paste it over here. So first we're going to print it as it's seen here. And then we're going to append the number 50, the integer 50, and we're going to print it again. And what we're expecting to see is first, it should output pretty much as we see it here, but then we would want to see it have that extra value on the end like that. But I'll take that off for now, and let's run it. And exactly as I've explained there, we have the list as it's declared, and the extra value on top, which is perfect. So what if we want to remove an item from a list? Well, you might have noticed when we were looking at the methods that are available, there are remove down here. So there's a few, and you should look these up to see what they all do, if any of them are interesting. Some of them are self-explanatory, for example, reverse or sort. But here we're going to use remove, and we're going to remove, let's remove the number 11. So you might be used to using the index at this point. So if we were, say, you know, printing something from the my numbers array, we would do square brackets and then we'd do 0, and this would print the number 2. But when we use the remove method, we are actually going to pass it the value of the thing we want to remove. So I'm going to pass it the number 11. And if I run this, you'll see the first time we print, it's exactly as we declared it, and then it's had the number 11 taken out in between 8 and 0. So there are a few duplicate numbers in here. We've got the number 2, the number 6. So what happens if we try to remove one of those? Well, let's give it a shot. So we're going to do my numbers dot remove 2. And you can see it removes the first one. It will only remove the first one within the list, and then it will stop. So this won't remove all of them, only the first one within the list itself, and that's going through the list one at a time based on the index. So what if we want to remove something that's in a specific position? Well, this time we'll use pop. So my numbers dot pop. So if I do my numbers dot pop 2 and run this, you'll see that the number 2 has stayed, but instead the here we are. Yes, the number 6 has removed. Yeah, it has. This gets confusing for me too. So number 2, number 5, number 6, and then this goes number 2, number 5, number 2, and that's because pop has removed the item at the second index position. So that's 0 is number 2, 1 is number 5, 2 is number 6. So that's why that has been removed when we've gone with the pop method. And finally, the other one which can often come up is dot clear. So you might be able to guess what this does. If I run it, it clears the list. This is the exact same as doing this, where we are redeclaring it as a blank list, but we can, instead of doing that, we can just call dot clear, and that's it does the same thing. But what is nice about using dot clear, even though they achieve the same thing ultimately, is by using this method, we know immediately that this already existed beforehand. So if we're scanning through this code and we see that this is being declared down here on line 7, we might not realize that it existed before this. So using dot clear on existing lists is a good way to make it obvious as to the state of that list and whether it already existed beforehand. So the final thing I want to show in this context of manipulating the lists is overwriting information. So I'll bring this back, and I think, actually, no, what I'll do is I'm going to make these, actually, before I do this, hang on, before I do this, I missed one, my numbers dot sort, This is a very common method because we often want to sort the items in our array, so I'll just run that real quick. You can see it sorted it by the number value. So anyway, where was I? So my numbers, let's get rid of the numbers because I think the numbers have been a little bit confusing. So apple, banana, and cherry. So we're going to go back to the old faithful my list equals. So if we print my list, then what I want to do is I want to change banana. I don't want banana here anymore. Bananas aren't good. what I will do is I will reference my list variable, and then I'm going to choose the index at which the piece of information is that I want to overwrite. And then I'm going to assign a value of grapes. And once again, we're now going to print my list. And if we run this, you can see that the second time around, our banana string has been overwritten with grapes. So this is exactly the same as dealing with variables, where we can create it and then we can reassign it and overwrite it. You can do that by referencing the indexes directly.